start with that. Let's say we use our same atom tool that we are using before. So new file. So the first thing to do would be to open the file. So let's say I make it file import. That's my variable. I do open. Now we check the file name, which is 5glog.txt. So 5glog.txt, and we need to do it for read only, so we can do RT. RT means read text. If you want to write on it, if we want to edit it, then we make it WT. That makes it write text. Now we need to do read only. We only need to read the values of RSRP and SINR. So we do RT. Now we need to save it as Python file. So we do, and we go save as, save it in the same directory where I have all the other scripts. So we can say log parse.py. So we can see now the colors are there, which shows that it's properly saved. Now what will happen is that Python will open this file, the text file. It will read it, and it will put all the file in this file import. So when I need to find RSRP, now I can work on this file import. So how we do that? The simplest way is to do a for loop. So for line in file import. Now what it means is that it will read every line in file import, and I say if RSRP in line, that is if while reading the line I finds out that RSRP is in the line, then I can just say print found RSRP. Now this is I'm just doing it to understand that whether it is working, our logic is working properly or not. So we save it, and we try to run this and see what happens. So we do py log parse. So it says yes. So we can see found RSRP. It is said multiple times. So it shows that it is possible to read this file. It is possible to read this file and find RSRP in it, and it was then only then this can be printed. Because if this is going into this for loop and then it's going into the if statement, and the if statement is true, only then it will print this out. That means we were able to find RSRP in the file import. So this is the first thing, just to verify that our system is working. Now we need to find the RSRP value itself. Now for that one, one of the easiest ways to do is to use regular expressions, also known as RE. Now RE in Python, it has many commands in it, so it is very powerful. It's very simple to use. So let's do that. In order to do that, we need to import RE. So we do import RE here, and then here we do let's find SINR. So SINR1 is equal to RE dot find all. So this is the command that we will use, and in this one what we can do is that we are looking for SINR is equal to, because if you remember here what we have, if you find SINR, we can see SINR is equal to is there. So we look for SINR is equal to. So every time the Python loop will work, it will try to find SINR is equal to in the lines where RSRP exists. So let's see how this looks like. If this is yeah, and we have to tell it here that it has to look in the line. So it will be like this, and we print SINR1. Now what is happening, what's going to happen is that the for loop will check each and every line inside this log file, and if the line has RSRP in it, for instance here we have RSRP, here we have RSRP, only then it will go inside, and within that line it will try to find SINR is equal to. So if it finds that, it will put that in this variable, and I can print that and see how it looks like. So let's see how it looks like now. Okay, so it's still printing that because I think we did not save it. So we save it now. Here you go. So now what we can see is that it is going into that line, and it is finding the SINR is equal to, and it is saving it over here. But what we are interested in, we are interested in these values, right? So we need to find these values as well. So how do we do that? Let me show you how we do that. So the easiest way to do that is to use this command. What this does is that after this value SNR is equal to, it will look for digits. D is equal to digits, and plus here means that it will look for up to as long as digits are there. I think it's up to 9, but we can also fix it. If we want only to look for 3 digits or 2 digits, we can do it like this, 1 comma 2, then it will only look for 2 digits. So but we're not sure how long the RSRP and the SNR will be, so in that case we can just put D plus. So in that case it should look for all the digits there are after this. So now it should find both SNR is equal to and the digits coming after this. So let's see if this works out. So now you can see that we can see SNR is equal to, and we can see the values as well here now, right? So now this is what we wanted, and we have found out that we can find our SNR values. Now so far so good, but if we want to actually plot that, then we just need this value, right? We do not need the whole string SNR is equal to. We only want this value 10, 11, 12, right? So we need to separate them to only look for this value, and let's see how we can do that. So using the same command re.findAll, we can do this. Let me show you how. So we do re find all. Now what I'm doing here is that this SNR1 is finding SNR is equal to the digits, whatever the value, and putting it inside this, right? So this SNR1 will be equal to SNR is equal to 10, SNR is equal to 9, SNR is equal to 8, but this one SNR2 is gonna look for only the digits. As I told you before, only the digits and not in the line, but within SNR2, within SNR1. So it should look only within SNR1, and it should only try to find the digits. So if that is the case, it will look within SNR1 and only find the digits, which should be 10, 9, 9, 8. So this is what I'm trying to do now, and I would like to print SNR2 now to see if it is correctly doing that. Right, so let's see. Let's go back to the command prompt, run the code. So here you see, now we only have the digits. So 10, 9, 9, 8, 6. So now we are able to remove the string itself, and we only have the digits. Now if we have that now, and we want to really make it work, we need to put it in some kind of a array or a list, right? So let's start a list as well. So we can say SNR is equal to, this is now an empty list, and I can append that value to this list. So how do we do that? Whenever I want to append that, I can use the SNR append command, and I want this to be appended in this list in every time the loop runs. So it should be an integer. So I make it integer SNR2, and because it is also sort of a list here, so we only take the first element, and only the first element exists. So we do SNR2 index 0, and that should be it. Now if it is correct, then we do print SNR. So it should show me all of these values of SNR in this list after the for loop has run. So let's see how this looks like. So here you go. So up till here we can see the values of SNR2, and this is the value of the list that we have created, in which we have put all of these values. So now we have a list of SNR which we can easily use for our further analysis and further plotting. So similarly, we need to do an RSRP one. So let's do that as well. So I can just copy it over here. See. So instead of SNR, now we're looking for RSRP. So I look for RSRP here, and similarly I want only the values of RSRP, so I do it here as well, and here is gonna be only in RSRP1. So something similar to what we did over there, and then we print RSRP2. Okay, now but here's a catch. Let me show you. There will be an error, but let me show you first how it will look like. Sorry, we need to print it. Okay, let me unprint this one. Okay, so now instead of RSRP values, I'm getting blank values. Now why is that? Because if you look here, the SNR was positive, so it is easy to handle. RSRP is a negative number, so this makes it a bit difficult to handle, and our this command /d positive d plus usually does not take the negative numbers. So the chance or idea to do that is this: if you put this in front of it, then it will also catch the negative numbers as well. So let's see how this looks like now. So here we are. So now you can see that negative values are also captured here. And similarly, we need to put this in a list. So I will make another list. RSRP is equal to this, an empty list. And I put here RSRP dot append int RSRP2 and 0. So there you go, and if this is correct, then if I print RSRP now, it should be should give me a list of all the RSRP values as well. So let's have a look at it. Here you go. So now we have all the values of RSRP in the list as well. Now in order to plot them, we also need to have a time domain structure, right? So if we look at this log file, we do not really have any time ticks, but we have the frame numbers, right? So it's a good idea to plot it against frame numbers. So using the same concept, we can simply look for frame numbers as well and try to cache them. So let's say we do SFN1 and we find SFN, and when we do here, let's say SFN2, and inside SFN1 we try to find that, and once we have done it, we also create another one, let's say frame num is equal to an empty list for that, which will now capture all the frame numbers from the SFN. So we do that similar concept as we did before for RSRP and SNR. So int SFN2 0, and then we can to verify that it's working fine, we can print frame num to understand that everything is working fine, and we do this and see. So here we have the frame numbers as well. So you can see 300, 302. So if you look at the over here, we have 300, then our next RSRP value is on 302, next RSRP value is on 304. So we have 304 here, RSRP minus 102, RSRP minus 102 at 304. So this shows that our loop is working fine, our code is working fine, and we are able to extract these values from there. Now let's say if we can plot them easily as well. So in order to plot them, we need to use a library which is a MatPlotLib. So to do that, let's say we need to import that here. Import matplotlib dot pyplot as plt. So this will import the matplotlib. This one is a library that is used mostly used for plots. There are other libraries as well, but I normally use this one. If you're using it for the first time, you will need to install it, and how to install it, let me show you as well. So you do here pip install matplotlib and you enter. Now once you do that, it will install the matplotlib for you. For me, because it's already installed, which is saying already satisfied, and I already have it. If you have, sometimes what happens is that when you are installing a new module into Python, it gives you a path error. there are multiple ways to solve that, but the easiest way is to actually install the Python with the path variable. If you remember, I showed the installation process for that in my video. So if you have a path error over here, you can actually go back to that video of installation and you can rerun that, and that should solve the problem. Now if we have this over here, so let's see, over here we can try to plot now. So I can just remove all of these prints commands so that we remove the clutter. Okay, so let's see how the plot looks like. So a simple plot file would be that if you go here and you do plt.plot, and you can put two variables here, so frame num comma rsrp. Now we know that these are the lists which contain both frame numbers and the SNR values, so and rsrp values. And here we can do frame num comma SINR, and then we can do plt.show. So plt.show, this will show us the plot. So let's see how this looks like. Oh, sorry, not this one, this one. So here we are. So now you can see that we have rsrp here and we have SINR over there. Now of course they are so distant apart because rsrp is in negatives of 100, SNR is positive. So maybe we can do it another thing, that we can do it separately. So plt.show. So now what will happen is that we parse. Now this is the first graph which has subframes, frame numbers here as well, and this is the rsrp. So we can see that rsrp is decreasing here, then suddenly from here onwards it starts increasing, and it's now stable around -95 afterwards. So if I close this one, then the next graph pops up, which is the SNR one. Again you can see SNR starts decreasing, and around about the same time it starts increasing, and then it's stable around 16-17 dB. So this is how we can plot the graphs. Now there are other aspects here as well. We also have throughput, we also have PCI. So let's quickly plot them together, and then we can see how we can plot a dashboard. So let's have a look at that quickly. So using the same concept that we were using before, so we can simply plot other elements. We can find throughput, we can find PCI. So let's do that quickly. And okay, let's first try throughput. So let's see. So throughput is equal to here. So this is the thing that we need to find. So we put this here. We can do THP1. We can call this THP2, and over here we can use then THP1. So this will give us throughput. Similarly, we want PCI. So PCI is here, so we find PCI, then we put here, let's say we could call it PC1, we can call this PC2, and we look into PC1. Similarly, we need to put lists here, so we make a list for PCI, an empty list for PCI, we initialize that there, and we put a list for throughput. So we initialize that as well. Now in order to put them into those lists, the same concept will go. So we do PCI dot append int PC2, and for throughput we do throughput dot append and int THP2. Now this should what you should do is that it should put all of these values into these lists, and we can directly plot them. So let's say plt.show, so frame num comma PCI plt.show, and similarly plt, sorry, here should be plt.plot. And we can also plot the throughput. So frame num comma throughput, and we can do plt.show. So this should now give us our throughput values and our PCI values as well. So let's see how this looks like. So we have, this is our RSRP, this is the SINR, this is the PCI values, and this is the throughput values. So now we have all of that over here, but in order to make a dashboard, we need all of the graphs to come together, right? All the figures to come together. So if we want that, how can we do that? That is where we can use the idea of subplots. So for subplots, we need to first tell how many plots we want. So we, over here we have 4 plots. So we can do figure comma graph is equal to plt dot subplots. So we can create 2 comma 2, that means 2 rows 2 columns, so we will get 4 graphs here, 4 figures. Okay, and for each of them, how to create it, we can create something like this. So we can do this one, can be the first one. So if you say graph 0 comma 0, so this will put RSRP graph in the first as the first graph. Similarly, we can put others like this, we 0 comma 1, this can be 1 comma 0, 1 comma 1, and throughput can be 1 comma 0. So this way we have now 4 graphs, and we don't need to do it separately, so we can only do it one time, the plot show. Let's see how this looks like now. So here we are. So you can see now the graphs are already together, but now we need to know which one is which graph, so we need to put the titles as well. See, so let's see how we can do that. So what we can do here is, we can, for graph 0 0, we know that it is RSRP graph, so we do Control C, Control V. Here we do set underscore title, and we set the title as RSRP versus SFN, right? See? Similarly, we can do graph 0 comma 1, this is SINR, graph 1 comma 1, that should be PCI, and graph 1 comma 0, this should be throughput. So now that we have all of them here, let's see how this looks like. So here you go. Now here we have RSRP versus frame numbers. Here we have SNR versus frame numbers. Then we have throughput versus frame numbers. Then we have PCI versus frame numbers. So looking at this graph now, we can parse any file. How big is it? We can parse it quickly, and it will plot us all these values. And if we look at this, we can quickly see that RSRP was going down. Because of that, SNR was going down, and throughput was also going down. Now, when the throughput and RSRP and SNR are going down, suddenly the PCI changes from 100 to, let's say, around 288. Once the PCI changes, that means we go to another cell, maybe it's a handover. So suddenly our RSRP starts increasing, our SNR starts increasing, and our throughput starts increasing. And after like reaching around this point, frame 340, our throughput is now stable around 480 Mbps. RSRP is stable around minus 95, and SNR is stable around 16 dBm. So we can say that on this PCI 288 we have a much better result. So this is how we can parse any data. We can parse multiple large amount of files as well, and we can plot them. We can make our own dashboards, and instead of doing manual labor for parsing a lot of data, big number of files, if they are drive test logs, they are L3 logs, any other log file, we can quickly find what we are looking for, and then we can plot them. We can even put them in a list, and we can do further analysis. So this was the initial show how to see how we can really plot items, how we can parse log files. In the next session, what we will do is that we will understand how we can analyze the issues. So right now we are only showing what is the values of these parameters, but in the next session what I'll try to do is that I will show you how we can use Python and make intelligent estimations of what the issue was, or what the problem was, why the throughput was low, why the SNR is low, what happened to mobility scenarios. So we can use Python to look at the log files and then give us an idea of what the issue was, and then if possible also a resolution and an optimization action, a recommendation of how we can resolve that. So hopefully it was helpful. If it was, please subscribe, do like the video, do share with others. Until next time, see you.